Good afternoon, everyone. Welcome to I Square Maths Academy, where numbers actually meets mastery. Today, we are going to be looking at integration by trigonometric substitution. Certain integral forms require trigonometric substitutions. In this class, we shall only consider integrals which have one of the following forms. A, the square root of a squared minus x squared, or 1 all over the square root of a squared minus x squared. B, 1 all over a squared plus x squared. In one of our classes, our previous classes, we discovered that if y is equal to the sine inverse of x, the y all over the x, the y dx will be equal to 1 all over the square root of 1 minus x squared. And we said if y is equal to the cos inverse of x, that the y all over the x will be equal to minus 1 all over the square root of 1 minus x squared. And if y is equal to tan inverse of x, the y all over the x will be equal to 1 all over 1 plus x squared. Now, these are the standard derivatives of these three inverse functions. Now, today we are going to be looking at integration of those three functions. Now, remember we said we are going to be going by trigonometric substitutions. Now, considering integral the square root of a squared minus x squared dx. Now, if you look at this particular integral, yes, the integrand, you will discover that this a square, a is the constant, and x is the variable. So you will see that here we have constant and here we have variable. So if you check the whole of this, you will discover that it actually matches this. Yes, square root of 1 minus x squared. So in this case, it means we're going to be substituting x to be equal to a sine theta. Yes, x is equal to a sine theta. Now, if x is equal to a sine theta, it therefore means that sine theta will be equal to x all over a. And theta itself will be equal to the sine inverse of x all over a. So that's theta. Now let's look at this again. Now let's call this equation 1. Yes, x is equal to a sine theta. Now if x is equal to a sine theta, now let's look at a squared minus x squared. Now a squared minus x squared will be a squared minus, now the value of x is a sine theta, so it becomes a sine theta all squared. So it means a squared minus x squared will be equal to a squared minus a sine theta squared is the same thing as a sine theta times another a sine theta. And that will give us a squared sine square theta. Yes, that will give us a squared sine square theta. So it means that a square minus x square will be equal to, if you look at this, a square is common. So it means we'll have a square in brackets 1 minus sine squared theta. Yes, a square minus x square is equal to a square in brackets 1 minus sine square theta. Now, from trigonometry identity, yes, we said sine square theta plus cos square theta is equal to 1. Yes, irrespective of the value of theta, sine square theta plus cos square theta must be equal to 1. Now, in this case, it means cos squared theta is the same thing as 1 minus sine squared theta. Yes, cos squared theta is equal to 1 minus sine squared theta. So it therefore means that a square minus x square is equal to a square in brackets cos squared theta. Yes, because cos squared theta is the same thing as 1 minus sine squared theta. Yes, so that is the value of a square minus x square. Now, coming to look at the square root of the value. So it means the square root of a square minus x square will be equal to the square root of a square cos square theta. Yes, a square cos square theta. So the square root of a square is a, and the square root of cos square theta is cos theta. So it therefore means that the square root of a square minus x square will be equal to a cos theta. Yes, that will be equal to a square cos theta. Now let's look at this value now. Here we have the square integral of the square root of a square minus x square. Then we have the x. It means this will be integral. The whole of this now is a cos theta. Then here we have the x. Yes, we have the x. Now let's look at equation 1. From equation 1. Okay, from equation 1. Now looking at equation 1 here, we have x is equal to a sine theta. Yes, x is equal to a sine theta. Now, the x all over the theta, when you differentiate a sine theta, it gives a cos theta. Yes, when you differentiate a sine theta, it gives a cos theta. So it means the x will be equal to a cos theta d theta. Yes, the x will be equal to a cos theta times the theta, and that will give us a cos theta d theta. So now let's look at this again. Integral the square root of a square minus x square, the x, which is the same thing as integral. Here we have a cos theta, then the x. So here we have the x. Now, but the value of the x is a cos theta the theta. So it means integral a square minus x squared dx will be equal to integral a cos theta, then the value of the x. And the x is a cos theta d theta. So the whole of this now will be equal to a times a is a square. Cos theta times cos theta is cos square theta d theta. So it therefore implies that integral the square root of a square minus x squared the x will be equal to, now because this a is a constant, yes, a is constant, so we can put it out. So here we have a square integral cos square theta d theta. Okay, now let's look at cos square theta. Now recall that cos 2 theta is the same thing as cos theta plus theta, and is the same thing as cos theta minus sine theta sine theta. So here cos 2 theta is the same thing as cos square theta minus sine square theta. Yes, cos 2 theta is cos square theta minus sine square theta. And from this identity here, yes, we said cos square theta is the same thing as 1 minus sine square theta. Yes, so it therefore means that here we have cos 2 theta is equal to cos squared theta minus, in brackets, we have 1 minus cos square theta. Yes, if sine square theta plus cos square theta is equal to 1, it means sine square theta is 1 minus cos square theta, and cos square theta is 1 minus sine square theta. So here we have cos 2 theta will be equal to cos square theta minus, opening this bracket, we have 1 minus minus is plus, then here we have another cos square theta. So it means cos 2 theta will be equal to cos square theta plus another cos square theta. That will give us 2 cos square theta. Then here we have minus 1. Okay, now cos 2 theta, if you bring this minus 1 here, it becomes plus 1, is equal to 2 cos square theta. So it therefore means that cos square theta is the same thing as cos 2 theta plus 1 all over 2. Let's take note of this. Yes, cos square theta is cos 2 theta plus 1 all over 2. Now, okay, now we are going to continue from there. It therefore means that the value of this integral the square root of a square minus x squared dx, which is the same thing as a square integral cos square theta d theta. Yes, integral the square root of a squared minus x squared dx is equal to a square integral cos square theta d theta. Then now looking at the value of cos square theta, bet cos square theta is equal to cos 2 theta plus 1 all over 2. So it therefore means that integral the square root of a square minus x squared dx, which is equal to a square integral cos square theta d theta, will now be equal to, it will be equal to integral. Now the value of this cos square theta is this. We have cos 2 theta plus 1 all over 2. Then here we have the theta. Now this is the same as saying the whole of this is integral. Now remember, here we have a square. We have a square. So now this will be equal to a square all over 2. Because this 2 is also a constant. So a square all over 2. Integral, we have cos 2 theta plus 1 d theta. Yes. So now the whole of this now will be, we have a square all over 2. Now here, the whole of this now will be integral cos 2 theta d theta plus integral 1 d theta. So it means now this will be equal to a square all over 2. Now when you integrate cos 2 theta, it gives sine 2 theta all over 2. Yes, when you integrate cos 2 theta, it's sine 2 theta all over 2. Then here we have plus. When you integrate the theta with respect to the theta, it gives theta. Then here we have plus c. So it therefore means that integral the square root of a square minus x squared dx will be equal to, here now let's look at this. So this times this, we have a square sine 2 theta, yes, sine 2 theta all over, here we have this times this is 4, yes, 2 times 3 is 4. Then here we have plus a square all over 2 times theta. That will be a squared theta all over 2 plus constant. Okay, but sine 2 theta is the same thing as 2 sine theta cos theta. Yes, sine 2 theta is the same thing as 2 sine theta cos theta. So it means integral the square root of a square minus x squared dx will be equal to, so here we have a square 2 sine theta cos theta all over 4. Then here we have plus a square theta all over 2 plus c. So here 2 here is 1, 2 here is 2. So it means we have a square all over 2, a square over 2. Then we have sine theta cos theta, then plus a square theta all over 2 plus c. Now the whole of this now will be equal to, we have the square root of a square minus x square, the x will be equal to, now looking at this now, so here we have a square all over 2 sine theta cos theta plus a square theta all over 2 plus c. Recall that x is equal to a sine theta. Yes, and if x is a sine theta, it means sine theta is equal to x all over a, and theta is equal to the sine inverse of x all over a. Good. Theta will be the sine inverse of x all over a. Now, but if sine square theta plus cos square theta is equal to 1, it therefore means that here x all over a all squared plus cos square theta will be equal to 1. And x all over a square is x all over a times another x all over a. And that will give us x square all over a square plus cos square theta, and is equal to 1. So making cos square theta the subject of the formula, it means cos square theta will be equal to 1 minus x square all over a square. So it therefore means that cos square theta will be equal to 1 minus this. So that will give us a square minus x square all over a square. That is this times this minus this over this. If you look for the LCM, it will give you the same thing. So if cos square theta is equal to this, it means cos theta will be equal to the square root of a square minus x square all over a square. So cos theta will be equal to, when you look for the square root, it gives you the square root of a square minus x square all over a. Yes, because the square root of a square is a. So now coming back to this, here, it means integral the square root of a square minus x squared dx will be equal to, here we said a square all over 2 sine theta cos theta plus a square theta all over 2 plus c. Now we know the value of sine theta. The value of sine theta is x all over a. The value of cos theta is the square root of a squared minus x squared, everything all over a. So it therefore means that integral the square root of a squared minus x squared dx will be equal to, we have a square all over 2. Now we have sine theta. Sine theta is x all over a. So we have x all over a. Now we have cos theta. Cos theta is the square root. Cos theta is the square root. Okay, cos theta is the square root of a square, minus x squared all over a. Now that's for this. Then here we have plus a squared plus a squared theta. Now remember, theta is the sine inverse of x all over a. So here we have sine inverse of x all over a. Now the whole of this all over 2. All over 2. Then here we have plus constant. So now it therefore means that integral the square root of a squared minus x squared dx will be equal to, now let's look at this. A times a is a squared. So this a squared will go with this a squared. So we have x all over 2, x all over 2. Then here we have the square root of a squared minus x squared. Here we have plus. Now let's look at this again. So this should be a squared all over 2, a squared all over 2. Then we have sine inverse of x all over a plus c. So now this is the integral of this function. So it means when you have integral square root of a squared minus x squared dx, where a is constant, it will give x all over 2, the square root of a squared minus x squared plus a squared all over 2. Then you have sine inverse of x all over a plus c. Now, thank you so much. We are going to be looking at more examples on how to use this particular integral to solve problems. Thank you and God bless you.